Welcome back to The Explainer. Today we are tackling something pretty massive. We're diving deep into the high-stakes, highly complex world of procuring and engineering a custom Dongfeng fire truck. Look, if you're a fleet director or an industrial procurement officer, managing this kind of capital expenditure while sticking to ridiculously strict safety standards is a fascinating challenge. So let's jump right into the source material and see exactly how it's done.
So think about it. How do you actually procure a custom fire truck without making a massively expensive engineering mistake? Because let's be real here. This is not just running out and buying an off-the-shelf commercial delivery truck. It's a complex engineering project where the stakes are quite literally life and death. You're dealing with massive, dynamic fluid shifts, you're integrating complex CAN-bus electronics, and you're making structural choices that absolutely have to perform perfectly under extreme pressure. Just one miscalculation, and you're staring down devastating structural incompatibilities and incredibly costly production delays.
To wrap our heads around this, we're going to follow a very logical, blueprints-to-build approach. We'll start with number 1, the foundation, which is chassis selection. Then 2, matching configurations to specific hazards. 3, engineering the superstructure. 4, crafting the perfect RFQ strategy. And finally, number 5, B2B procurement and logistics.
All right. Let's dive into part 1, the foundation, chassis selection.
You can really think of a custom fire truck just like building a house. If your foundation fails, the whole superstructure comes crashing down. When a heavy-duty fire truck is bouncing over rugged terrain, it is carrying fully loaded, sloshing reservoirs of water and foam. The dynamic fluid shifts happening inside those tanks create immense kinetic energy. And that right there is exactly why a proper industrial-grade, heavy-duty frame is totally mandatory. It is the only way to prevent a catastrophic chassis failure.
Now you might be wondering, why do so many fleet directors specifically spec out Dongfeng platforms instead of those super pricey European alternatives? Well, it really boils down to sheer performance and practicality. When we look at the specs, we're dealing with heavy-duty Cummins or Yuchai diesel engines. These power plants deliver immense low-end torque. And that's crucial because you have to drive incredibly heavy axles and high-pressure fire pumps at the exact same time without the engine ever stalling out under pressure. On top of that, there's the incredible global parts accessibility. Routine consumables, think air brake components or fuel injectors, they're available basically everywhere, which means less diagnostic headache, and more importantly, your emergency vehicle actually stays in active service instead of sitting in a maintenance bay waiting weeks for a proprietary imported part.
Moving right along to part 2, matching configurations to hazards. Drive types. Look, matching the machine to its actual real-world operational mission is entirely non-negotiable. Take a 4x2 configuration, for example. It is absolutely perfect for tight urban municipal streets where you really need that short wheelbase to make tight turns. But if you're procuring a truck for a massive petrochemical facility or a refinery, an 8x4 platform is mandatory. No exceptions. That's because you have to support these massive dual-agent payloads, water and foam together, that often exceed 20,000 or even 30,000 liters. An undersized chassis simply cannot support an industrial-grade foam system, and conversely, a massive 8x4 literally can't squeeze down a dense urban alleyway. You have to match the tool to the hazard perfectly.
Okay, part 3, engineering the superstructure, tanks, pumps, and the PTO.
This is a really critical engineering concept right here, the PTO, or power takeoff mechanism. For any full-scale fire apparatus, what's known as a sandwich-type full-power PTO is strictly required. Basically, this transfers the raw rotational power of the engine directly into the centrifugal water pump. It allows the rig to blast water at maximum pressure while sitting totally stationary. But even cooler, in specific configurations, it allows for pump and roll operations, which is an absolute must so the truck doesn't just stall out while crews are actively fighting a moving brush fire.
So, what kind of water output are we actually talking about here? Generally, you're looking at 40 to 60 liters per second. That's your standard discharge rate at normal pressure for domestic CB10/40 or CB10/60 pump models. Procurement officers have to specify these exact flow rates based on their local fire codes. Now, if you need extreme vertical reach, you absolutely can spec out imported ultra-high pressure systems, like those from Darley or Hale. Just keep in mind, asking for those imported systems is definitely going to extend your manufacturing lead times.
But obviously, beyond just the pumps, you need a place to safely hold all that fluid. Like we mentioned earlier, fluid surging during transit creates immense kinetic energy, so right off the bat, every single tank has to feature internal welded baffles just to keep the truck stable. But the material selection is where the real trade-offs happen. If you're only transporting clean water, Q235B carbon steel is a great, cost-effective choice as long as it has internal anti-corrosing epoxy coatings. But if you're carrying Class A or Class B chemical foam concentrates, 304 stainless steel becomes your new baseline. And for severely corrosive environments, you have to upgrade to 316L stainless steel.
The stakes on this are just incredibly high. As the specs point out, 316L stainless steel prevents rust scaling that clogs delicate pump impellers. If you cheap out on your tank materials during the procurement phase, those corrosive chemicals will inevitably cause rust scaling. That scale eventually chips off, flows right into the pump, and literally shatters the delicate impellers of the water pump at the exact moment you need it to save a building. Getting this wrong doesn't just limit the truck, it creates an active hazard.
All right, on to part 4, the perfect RFQ strategy, or as I like to call it, paperwork that protects.
Executing a highly precise request for quotation, or RFQ, literally dictates whether your custom build succeeds or fails. Vague specifications just lead to mismatched engineering and completely inaccurate pricing, whether you're negotiating FOB or CIF shipping terms. Now, when you source through specialized B2B platforms like CN Special Vehicle, you actually get direct access to the OEM engineering teams, which cuts out a lot of middlemen. But you absolutely must provide them with these 4 exact parameters. Number 1, you have to explicitly state left-hand or right-hand drive. Number 2, exact emission standards like Euro 3, 5, or 6 to ensure you can legally import it. Number 3, precise media capacity volumes for your water, foam, or dry powder. And 4, specify your cabin type. Do you just need a standard day cab, or do you need a double-row crew cab to fit 5 to 6 personnel?
Once those specific parameters are locked in and the factory actually issues precise engineering drawings for your final approval, you're usually looking at a custom production timeline of about 45 to 60 days. Now, here's a crucial piece of advice. Do not skip validation. Before that truck ever ships, reputable OEMs will help facilitate factory acceptance testing, or FAT, or even third-party SGS inspections. You need someone to independently verify those pump flow rates and the structural integrity before the vehicle ever rolls off the factory floor.
And finally, part 5, B2B procurement and logistics, delivery and beyond.
Let's quickly run through the final deliverables and logistics. First off, because of the high level of customization, the minimum order quantity is typically just 1 unit. You're going to get a standard 12-month structural and engine warranty. But here's a massive pro tip. Always negotiate a wear and tear parts kit right into your initial contract. Getting those extra filters, pump seals, and PTO belts up front saves you so much downtime later. Also, if your department needs an advanced CAFS, that's a compressed air foam system, you have to specify that super early because it requires specialized plumbing and much higher capacity PTO units. Once it's all finished, these completed fire trucks are transported fully assembled via roll-on/roll-off ocean freight or on a flat rack. The factory then hands over a complete set of export documents, everything from the bill of lading to your standard ISO and CCC quality certificates, so you can easily handle your local road registration.
So we've walked through the foundation, matched the hazards, engineered the superstructure, and dialed in the logistics. I want to leave you with this one provocative question to help you evaluate your own procurement pipeline. Are your RFQ specs precise enough to prevent a structural failure? Because, as we've seen today, the ultimate success of your emergency response is actually built at the factory level. Thank you so much for joining me on this explainer. Keep learning, keep standardizing those specs, and I'll catch you next time.